So here we are in 3.3b, College Algebra, and we are on example number 3, and just kind of bouncing around here a little bit. They're giving us f of x equals 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8. And they want you to find f of 10. So basically what they're doing is they're saying take 10 and plug it in here for all my x's. Okay? Alright, so we're going to do this a little bit differently than taking this 10 and putting it in each one of these. Okay? We're going to do it a different way. We're going to use synthetic division because remember what I said is we're looking for the y value, f of 10, when x is 10. Okay, so that's what this is doing. When we put 10 in here, when x is 10, and we put it in here, my f of x, or my y value, is going to be 170,802. That's the point. So I'm going to go over 10, up 170,802, because this is the answer I get when I put 10 in that equation. Okay, lots of work in order to do that. Alright, so if you remember what I said, if we put this number and we divide it into this, my remainder will always be the y value. It may not always be 0, but it will always be the y value. So that's what I'm going to do, is I want to find the y value. So I'm going to put 10 here, and I'm going to write this out, 5, 4, 3, 2, 1, 0, so everything's good there. I don't have to put any placeholders in there. That's a negative 8. Okay, so let's do our division. 2, 20, 17, 170, 171, 17, 10. And this is one of the nice things about learning how to do synthetic division and getting good at it is you don't have to, you can actually talk while you're doing it, and I'm just copying down from the book, but so again, bring down the 2, this times this is 20, this plus this is 17, 10 times 17 is 170, add, this times this is this, add, this times this is this, add, this times this is this, add, and you get a remainder, because you're at the end, so you know that's the remainder. So I know that when I plug 10 into here, I get a remainder, and that remainder is my y value. Okay, so very, very important to remember that. And I explained why that worked, but if you're still having a struggle understanding why it works, let me know. Alright, so example 4 says determine whether negative 4 is a 0 of f of x when f of x equals x cubed plus 8x squared plus 8x minus 32. Alright, so we are trying to find out if this is a 0, if that is an answer that fits this graph. At this point, negative 4, when x is negative 4, is that where this graph crosses the x-axis? Now it crosses at 3 places, but is this negative 4 one of those places? So that means at negative 4, does my graph cross there? Okay, that's what I'm trying to figure out here. So they're saying, okay, so I'm giving you one number to try, and you tell me whether it crosses there. Alright, so if negative 4 is a 0, then negative 4 and something gives me 0. Okay? So that means negative 4 plus 4. So when x is negative 4, if this is true, if this is actually a 0 of this equation, because it makes it 0, negative 4 plus 4, then x plus 4, x is negative 4, would be a factor of this. Okay, so what I do is, if you remember right, when I do synthetic division, the number that goes here is always what makes that 0. So in this case, it is the -4. Then I write this. I have a 3, 2, 1, 0. So everything is the way I want it. Okay. Draw a line. Bring down the 1. Multiply -4 times 1. Add. Multiply. Add. Multiply. Add. I get a 0 for a remainder. So the question is -4 a 0 or a 0 of f of x? It is, because if -4 gives me a remainder of 0, that means the point -4, 0 is where this graph crosses the x-axis, and wherever it crosses the x-axis, it is at this point here, and it is a 0 of this equation. It's an answer. Okay, so whenever the y value is 0 or the remainder is 0, then this number right here is where this graph crosses the x-axis. Okay, got it? Got it. Alright, it's just going to take practice to do this synthetic division over and over and over, but pretty soon it'll start coming really, really fast, and we're going to be doing a lot more of it, so it will definitely come. Alright, so we have f of x, this is example 5, equals x cubed minus 3x squared plus x minus 3. Alright, the question is, determine whether I is a 0. Okay, that's kind of weird. Make our box, put an I there. 3, 2, 1, 0, that works. 1, -3, 1, -3. Line, and don't get freaked out about that I. It's not really that big of a deal. Bring down the 1. 1 times I is I. Okay, add these two together, and we get -3 plus I. Multiply I times this. We get -3I plus I squared. And if you remember, I squared is -1, so we're going to put -1 there. Add these two, so -3I minus 1 plus 1. These two cancel, so we just get a -3I down there, right? Alright, so now we're going to multiply I times -3I, and we get -3I squared, or -3I squared is -1, which gives me a 3. Add those up, get 0. So the question is, determine whether I is a 0 of f of x. Did I get 0 for a remainder? Yes. Therefore, I is a 0 of this. I goes evenly into this. Okay? Okay, this next section is rather short, but there's kind of a lot here. And again, I'm one that I like you to understand it even when the book just kind of gives you a little bit here. And this is finding factors of polynomials. So the way this works is, let's say that you have a polynomial like that, and you're wanting to find the linear factors. Okay, we had talked about having to do this later on, and we're going to use synthetic division in order to find the linear factors. Now right now it's kind of pretty much a trial and error thing. We just do synthetic division. We just pick a number and see if it goes evenly into this. If it does, if we get a remainder of 0 when we do synthetic division, like if I just pick -5, and I did -5, and I did a 1, 2, -5, -6 here, and I did my synthetic division, and I ended up with a 0 here, then this is a 0 of this equation. Yay! Which means that one of my factors would be x plus 5. Okay, it's always going to be the opposite of that because this is really negative 5 plus 5. Put negative 5 in here for x and get 0, so that tells you that it's a 0. All right, so if that gave me a remainder of 0, then I know that divides evenly into this and is a factor. So I just grab a bunch of different numbers and find them. Once I hit 3, remember, this tells you how many factors there are, then I'm done. So that's kind of a check there to find out, when you're done or not. And remember, it's at most 3 because sometimes you can have a multiplicity of 2 or 3, which means you're only going to get one value, but it occurs 2 or 3 times. So keep that in mind. So anyway, that's what we're doing here. Let's get rid of some of this and go to town here. So for example 6, it says let f of x equal x cubed plus 2x squared minus 5x minus 6. Factor f of x and solve the equation f of x equals 0. So the first thing they're asking us to do is factor f of x. They're asking us to factor this. Okay, so let's try. Okay, I'm not going to try this negative 5. I know that doesn't work. Let's grab one. Let's try a factor. Let's see if x minus 1 divides evenly into it. So that means that over here we're going to put what makes this 0. So we're going to put a 1 here. And 1, 2, negative 5, negative 6. Do our synthetic division. And I don't even have to continue. I know I'm going to get a remainder. I'm going to get negative 7. Okay, actually, if you look here, and when you get to this point here, and you get a negative 1 here, and you know, oh, when I multiply it by this, am I going to get this? If I'm not, in opposite sign, because the only way to get a negative remainder here is for this to be a plus 6. Well, if I know multiplying this times this is not going to give me a plus 6, I can just stop and say, nope, that isn't going to be a factor. So I can stop there. So I know this doesn't work because I get 7 is a remainder. All right, so what does that mean? Well, it just means that I keep going with other numbers. So let's say I'm going to try x plus 1. So that means this is going to be a negative 1, and again, everything else stays the same. And I just do this over and over and over until I find one that is going to work. Oops, this is a negative, right? So I get to this point, and I don't even have to stop, or keep going. I know I get 0 there, so I know x plus 1 works. All right, now notice what happens here. When I do x plus 1 and I know it works, this is what I have left. So then I write this in equation form. Now remember the first one, it's this minus 1, so this is going to be 1x squared plus 1x minus 6. Okay, this is what I have left over. When I factored out the x plus 1, this is always what I have left over. Now this is what's really important, and I don't know the book even talks about this, but I have to keep factoring this until I get an equation that's quadratic, that has a 2 here. So if this is a 3, I have to find one factor, and then I can solve this using completing the square, quadratic equation, or just factoring it into 2 binomials. Okay? But as long as, so if this number here, whatever amount, this is bigger than 2, that's how many factors I have to find before I can use this quadratic equation, let's say. So if this were an x to the 5th, I'd have to find 3 factors in order to have an x squared something left over so I could actually do the factoring. So now I have that x squared, and I can real easily factor it down to x plus 3 and x minus 2. So I took this and factored it there, and there's my answer. Now I could go ahead and try negative 3 up here and then 2 up here and get my 0 remainder, but it's usually easier once I get it this way to just factor it. Okay, so that's it for 3.3b.